Okay, I'm going to give you some flashbacks to grade 9. Okay, here's a grade 9 flashback. What did you do here when you had exponentials and you were multiplying them? You add them. So if these were multiplied, you added them. Okay, that was kind of like a rule you learned, right? So what did you do in grade 9 with something like this? X to the 6th. So here, if you divided, then you subtracted, right? This is stuff you learned in grade 9. And what would you do if you had this? Then you multiplied. Okay, so those were all the exponential rules that you learned in grade 9. And now we're going to do the same rules with logs. Okay? So just think about those rules because I'm sure you still remember those, right? Yes, Ms. Falk, I do. Okay. So, product rule. If you have two things multiplied, so I'm going to give you an example here on the side. Log A of 4 times 5. So, if two things are connected with multiplication, what was the thing? We could split multiplication with adding. So log A4 plus log A5. So if we multiplied the original, we're going to add. Separate and add. Quotient rule. Okay, so if two things are divided, so that would be a division of something. We can separate them with subtraction. Okay, and then the power rule, so an exponent, so log A 4 to the 5th. So if there was, remember our grade 9 rule? If we had an exponent, then we decided to multiply. Exponents, we multiply. So this is going to become 5 times log A4. Okay, so they follow all those things that you learned about exponents. If this is multiplied, split with add. If it's divided, split with subtraction. Exponents become multipliers. Okay? Okay, so here we go. We're going to expand these two. Okay, so how many units am I going to have when I expand? I'm going to have 1, 2, 3 different separations. Okay, and they all are going to have a log A. Okay, A is always the base. Okay, ready? So this has an exponent. So instead of exponent 3, it's going to be a multiplier. Okay, now the y, this was connected with multiplication. So I'm going to split it apart with an add. This z part is a divider. So when I split dividers, I subtract. And then it had an exponent of 2, so the 2 could become a coefficient multiplier? Okay, next example. How many different separate units am I going to have here? So there's going to be this, 1, 2, 3, and 4. Okay, so that number 4 is its own thing. The Z's sixth is its own thing. Okay, we've learned this already. A square root is the same in math as doing an x to the, do you remember it? 1/2. A root, a square root, and a 1/2 exponent. Okay, ready? So the first is going to become 1/2 log 5x, because exponents become multipliers. Exponents become multipliers. The y, that was connected with multiplying, so now I'm going to add it. The 4 is a divider. The 4 is a divider, so I'm going to subtract log 5, 4. And the z piece is also a divider, because it's on the bottom, it's a divider. So I'm going to subtract 6 log 5z. Okay, so maybe this confused some of you. Well, the z is connected with multiplication to that. Okay, if that was the case, I would be subtracting I could connect those with add because of the multiplication, but then I would have to make a statement that I'm subtracting all of that, which would turn into subtract. Okay? Is that clarified if some of you are confused? So you basically just have to say, is it on the top or is it on the bottom? If it's on the bottom, you're going to be subtracting, right? Because it's a divider. Okay, now we're going to work backwards. This is expanded out, and I'm going to try to put it all together, back together. So just backwards of what we just did. Okay, so they all had a log 7. Okay, so the first thing is, well, this one had a coefficient 2, so the 2 could now become m squared. This was a plus, so that's a multiplication, so times n. This is a subtract, so it's going to be a divider, so y to the 4th on the bottom. And this is a term that's a subtract, so it's also going to be a divider. So we just put it all back together. Okay, and the stuff on the bottom here, I'm just not going to be doing this last thing, so. Okay, I gave you 3 things here. I gave you the log of 4, the log of 5, and the log of 8. Okay, I want you to think about how you could make a 20, and you're only allowed to use a 4, a 5, or an 8, and you're only allowed to multiply things, divide things, or exponent things. How can you produce a 20 using a 4, a 5, or an 8? Anybody think of a way you could get 20? 4 times 5 is the same as a 20, right? Okay, so what do I do if I want to separate that? What's the rule? If this is multiplied, then I could separate with addition, right? Multiplication splits addition. Okay, now I know. What is log A for? 3.419 plus 3.969. Da, da, da. So 7.388. Okay, now, you ready? I have to think. How can I create a 16 using a 4, a 5, 8, some kind of combo? I'm only allowed to use multiplication, division, or exponent stuff. Can anybody think of a way to make 16? Did you get something? 4 squared. 4 squared is a way I could have made 16. Okay. What do our rules say we could rearrange this? We could. The exponents become multipliers. So 2 times 3.419 6.838. Okay, 1.6. You have to come up with a combo to get a 1.6 using a 4, a 5, or an 8. Anybody think of something? 8 divided by 5, yep, that would work. 8 divided by 5 is 1.6. So what can you do with the rules? If something is connected with division, then I'm going to split them apart and subtract them. Okay, and then we just fill in our numbers here. Okay, here's the last one. I made a little bit of a challenge here. How to get to 10. How are you going to get to 10 using a 4, a 5, an 8, multipliers, dividers, or exponent stuff? How can you make an 8, or a 10, sorry. Ooh. 5 times 8 divided by 4, yep. I was thinking of something else, which I'm going to do because it's a little bit trickier. But yes, yours would work too. So I'm going to do this one just because I wanted to do a little bit more of this rule. Because this is 5 times 2, essentially, right? Okay. How do you separate this using all the rules you know? So log A5, so that would be a plus. How do you do the square root? Do you remember? Square root of 4 is the same as 4 to the 1/2. So now this is going to become a half log 4. So Rory, I'm curious if you want to do yours the other way to make sure we get the same answer. That'd be good. Okay, so splitting them up with the rules, we split a multiplication with an add, we made an exponent a coefficient. Okay, so I definitely put one of those on your test. I just made your test. I put one on there. So you have to think about the combos to get your numbers and then how you're going to split those apart with the rules, okay? Okay, and we'll just do these 4 and then we're done. Okay, let's remember these things here. So you always need to have these in the back of your mind. Exponential form is base to an exponent equals a result. That's an exponential form. Some kind of base to some kind of exponent equals a result. Log form. How do you always think about your log form? Log base result equals an exponent. Okay? So we always think about logs, the output, the answer is always the exponent, right? Our backwards brain thinking. Okay. First one here, would you say that this is an exponential or a log expression? It's exponential, okay? Because this is the base to the exponent, and I guess we can say it would equal some kind of result, right? Do you see all my components? If I label them, that's a base, that's an exponent, and it would eventually equal something, right? I'm evaluating it. Okay. Can you take that and change it to a log? So log.
Did you say that the one after the log was a base? So why did you label it exponent?
Oh, I labeled this entire thing as the exponent. Does that make sense? 8 to that whole thing is the exponent, yeah. Yeah. Okay, ready? Log. So I'm going to make it a log. So log, so I need to put the base down here. Result equals the exponent. Okay. When you look at this, do you have a conclusion about what my question mark has to be equal to? 70. Therefore, this expression is 70. So this is a rule. So I have it up here. So if this base is the same as this base, it will always end up equaling that value. Okay, so this is a rule. It's up to you if you want to just memorize a rule, or if this is me thinking about why. Why does that rule happen? Okay, let's do this one. So this is a base. That's a base. This is, all that is an exponent. And it equals something. A base to an exponent equals something. Okay, so can you put that into a log form? So I'm going to go log baby, I call it a baby 4. Log baby 4, the result is what I'm trying to figure out. equals the exponent. Okay, now there's something different about this one. It's the 3. I don't like the 3. Do you now know something else you could do with that 3? What could you do with that 3? If it's a coefficient multiplier, where else could it move to? An exponent. Okay, so now both of these are log 4. So the conclusion is my question mark would be the result is 5 cubed, but I'm going to say that's 125. Okay, so that was almost the same except for we had to involve the multiplier with our rules. Okay, and this last one, last two. Okay, log 464. What's your brain thinking? What's the exponent? What's the exponent? That's what your brain is thinking. What's the exponent? That's what your brain is thinking about, that value. So what is that value? Anybody know that one? 3. 4 cubed is 64. Okay, on the bottom, I had this expression. So your brain is saying, what's the exponent that made this happen? So base, what's the exponent that made that happen? Anybody know this one? What's that exponent? 1/2. So what is 3 divided by half? It's also the same as 3 times 2. Okay, so that whole expression comes to be 6. Okay. Ready, what is log 216? Log 216. So what's the exponent that makes that happen? So what's the exponent that makes that happen? Two to the 4? Okay, so that number is 4. Okay, now I have a new expression, so I'm thinking, what's the exponent that makes that happen? So what is my brain doing? What's the exponent? What's the exponent that makes that happen? Did you pick? 1/2. Okay, so that whole expression comes out to 1/2. Okay, so I already know on your test, out of those 4 examples, I put two of them on there.